So, Vanakkam. So, we will continue our lecture on engineering seismology. So, we have been discussing about the seismic microzonation, and then we also seen a different component and then a different work done in India in the name of microzonation. So, we have been highlighted that even though a microzonation is needed, okay, to classify, delineate a cities, okay, so which has a different hazard potential, but the work complete microzonation was done only for the few cities in India, which has been realized by the ministry, okay, particularly Ministry of Earth Science. Okay, they have taken up initiative for the microzonation of Indian cities, which has a large number of population. Okay, cities which exceeding the some X, I think the 5 lakh and above cities they identified, and then they taken up is so that the uniform microzonation procedures will be adopted all the location, get a more reliable robust microzonation map. Okay, so the presently microzonation of Bangalore, Delhi, Guwahati are the more classical work which is completed and be taken as a reference, okay, for the microzonation related studies in the India. Okay. So, with this context we also want to discuss what is the global macrozonation level and what is the Indian status on macrozonation level. So, the work which I am going to discuss this class and next class will basically accessed from the global earthquake analysis, okay, which is done by the different scientist group all over India. You can see these websites to get a more information about the microzonation. So, when I talk about this website, I also need to highlight that the microzonation map, even though many of the microzonation map produced, okay, so in the lower scale and then maybe the accurate way, there is no iterative map, okay, or the user interaction map, okay, so which is one of the a basic essential requirement for the any mapping entity, because the user interface means like when I zoom into the particular location, okay, I should get the details of the map. Okay, so this microzonation studies published by the different people earlier as available as a report, okay, map, but not a website user interface map. So, I think the MOES, okay, the NDMA and the MOES, they are planning to create such kind of maps which will be useful for the all the people in the India as well as outside India. So, that map how it will be, if you know this map, then you can know how that map will be on this. So, the global earthquake model, okay, so initiated by the a scientist group of scientists, okay, so then they gathered from the each region and try to generate map, okay, in the similar form throughout the world. Okay, that was the one of the classical way. So, I told you that all this information what I am going to discuss today and tomorrow on this topic is actually taken from the website which I shown you previously, like all these websites which we have taken. So, I acknowledge those people, and I also say that these materials are only used for the teaching purpose to explain student how they have done and what was the the highlight of this work. Okay, so that is the reason I have been quoting this website. So, thanks for providing these materials in the website. So, where the people, the teachers and students can benefit out of this kind of materials. So, the global seismic hazard assessment program, okay, is not the new one. Okay, so this was actually started in 1991. Okay, so by the International Lithosphere Program, that was the first global level attempt to prepare a seismic hazard map of the entire globe. So, earlier people are very pioneer on this area, they may concentrated on preparing hazard map on their own region, not for the entire globe. So, the group of scientists, okay, try come together, okay, then they started International Council for Scientific Union. Okay, so, they endorsed and demonstrated the framework for the United Nations International Decade for the National Disaster and Reduction, and then they started a GSHAP project. Okay, so, this is a global seismic hazard assessment program in 1992. Okay. So, this was actually the scientist, the group of scientists, okay, who are involved on this basically. So, these are all the group of scientists they involved on that and try to get a map of the entire globe. So, basically they produced a global seismic hazard map, okay, which depicts the seismic hazard as a peak ground acceleration with 10% probability of exceedance in the 50 years corresponding to return period of 475 years. So, this we will be understanding when we are talking about the probabilistic seismic hazard analysis. So, right now only remember what they have taken. So, this they have done for the entire globe. So, let I focus only on the Indian context. So, the India and adjoining regions, okay, so bound by this much the latitude and longitude has been taken. A working catalogue of main shocks was prepared by merging a local catalogue with the international catalogue produced by removing the duplicate aftershock and earthquake with different magnitude. We told that the foreshock, aftershock should be removed for the any analysis. So, removing of that kind of foreshock and aftershock is actually a declustering process, which we will discuss in the later stage, but just we discussed earlier. So, the foreshock after, so they removed and then they delineated the seismic source. So, 86 potential seismic source zones were delineated based on the major tectonic features and seismicity trend in the India. Okay. So, that we will see what is the 86. So, using the probabilistic seismic hazard analysis, which was developed by the macro and adapted by the GSM. So, basically those GSM group suggested, okay, they used to a similar kind of package. So, they tried to estimate a PGA, peak ground acceleration, with a 10% probability in 50 years exceedance for the grid size of so much. Okay, they mapped that and then they taken that map as a global seismic hazard map for the India to represent in the global scale. So, here you can see that they said that there is no reliable estimate of attenuation values are available for Indian region during 1992. The attenuation relation was Joyner and Boer was used. So, now you may understand that when we talk about the Jabalpur microzonation work, I also told that they were used Joyner and Boer ground motion prediction, the ground motion prediction equation or attenuation relation. You can see here also they use. So, if you want to get the about more information about that, you can visit this website about this. So, this is the basically what they did. They estimated the grid, each grid PGA, okay, and then mapped that PGA as a contour, and then the most North Indian plate boundary region and Tibetan plate region have the hazard value of so much. Okay. So, with the predominant high the order of so much in the seismically more active zone with the Burmese arc and Northeast Indian and the Hindu Kush region. So, these are all the value they got so much. In the Indian shield, the regional seismic hazard covering the order of so much. Okay. Whereas some areas Koina and hazard value was so much 0.2 G. The present map, okay, can be converted into conventional seismic zonation map, the 4 zone where the hazard value was so much and so much, so much. So, this is how this was the comparable with the present zonation map. So, this is basically the 86, okay, 86 potential seismic zone you can see. So, like that a different potential seismic zone. So, they consider the entire India plus the Bangladesh, okay, so this side Nepal, so this side even a part of Pakistan has been clubbed together. Okay. So, then this is the source zone they consider. So, using this, okay, they used as I said that Joyner and Boer equation 1981. Okay. So, they used that equation and then they try to estimate PGA. Okay. So, as you know that the GMP or predictive equation is the function of any ground motion parameters. So, this is the function of PGA. Okay. So, they estimated the PGA. Okay. Then using the probabilistic seismic hazard analysis and then given a map, you can see here. Okay, so these are all the places very where they have given a G value of 0.5 and above. This one. So these are all the places where the G value of 0.3 and above, and these are all the places even the G value of less than 0.05. You can see the Bangalore. Okay, so South India, Bangalore. Okay, so you can see the very low seismic hazard. So the Delhi, I think this is maybe the Delhi. So where you can see the hazard values are close to around 0.15 to 0.12. Okay, so that is the global seismic hazard map prepared first time by the global community with the support from the Indian author. So the work was carried out by NGRI, the scientist called Bhatia et al. So these publications are available. Bhatia et al. 1999 work, you can see this is the global level measure. So this is basically a hazard distribution map. So this here the PGA in the meter per second square. Okay, so previous one what we have shown in the G, then you can see the this is the map which is given for the Asia region where the Indian data has been merged with other region they prepared. You can see the acceleration, so expected meter per second square. So he consider Bhatia et al. Consider the seed and Joyner and Bohr ground motion prediction equation and focal depth of 10 kilometer. So the 10 kilometer focal depth throughout the India is actually very low values, but in spite of that the hazard value estimated are having a very low PGA or very low accelerations. You can see which is not basically appropriate. So this work was reviewed by me, and then we also published a paper when we are talking about that. So we highlighted that what was the reason to get a low hazard value, that is you can see the Sitaram and Anbaragan 2008 paper. Okay, so where the lesser PGA resulting from the DSHAP study may be due to the following reason. One is that the study was carried out on a macro scale. Okay, the scale of the study was very large. The attenuation relation, basically the Joyner and Bohr 1981 used in the study was proposed elsewhere. Okay, and that is not applicable to the entire Indian region. So as we have talked about the Indian region, we have been discussing about the plate boundary. So we have been discussing the plate boundary here, correct? This was the somewhere the plate boundary. This is the plate. So this is we have seen that there is a plate boundary, intra-plate earthquake. Okay, so inter and then intra. Okay, the earthquakes on these places, even a mid plate somewhere in this area. So considering all of them is a similar and using a same ground motion prediction equation is not appropriate. Okay, that was highlighted by our research team. Okay, and more further we also found that the few seismic source based on the local and major earthquakes were used. So the number of sources has been taken based on the past earthquake. You can see that they found that there is no seismic source on these areas. There is no seismic source on this area. This area no seismic source. So basically the active fault study, okay, the fault activity, the seismic activity potential may cause future earthquake is not explicitly modeled in the GSHP map generated by the Bhatia et al. 1999. So that is the message we can take from here. Okay, so that's why the source are described based on the constant of seismicity. So they taken a past seismic record and consider that the sources are only located on those location. As we told that India has recording from 1960. Okay, that means we have only data when this map was carried out, we have only less than 40 years earthquake data. So this data may not be sufficient to really delineate a source. Okay, they should have considered some of the advanced technology like satellite based image, okay, so or the geophysical survey and geological studies, and then delineated the active source, and if they consider, then the map value what they are given will be different than the map what it was produced. So this was the first the geological seismicity integrated hazard analysis done for the global seismic hazard program by the Indian contributors, particularly the Bhatia et al. But this was that time this work itself a more appreciable way, because in 1992 and 95 regions very few people work in India on seismic hazard analysis. There is no even people to teach this kind of subject. As I told you that the earthquake geotechnical engineering is origin after Bhuj 2001 earthquake, the first earthquake geotechnical engineering subject, okay, where the amplification, liquefaction, ground shaking hazard has been come into teaching level after the Bhuj earthquake after 2004. Before that, no such kind of things are there. Only there are two agencies who use this kind of study. One is by the earthquake engineering department at Roorkee, and then the NGRI, National Geophysical Research Institute in NGRI. They only do. So the Bhatia was part of the NGRI. They did this work, which is appreciable at that point of time, and maybe the more depth of information should be handled in the producing that map, which might have been more useful. But anyway, so that was anything which happens in this region, as I told you that anything which happens with respect to seismic hazard estimation, seismic source characterization, seismic microzonation has to be reviewed at every 5 years interval and updated. Okay, it has to be frequently need to be updated with interval spacing. So after this effect, there is no such kind of any attempt has been done in the national level to cover a very big large area. Okay. So then there was a group which was started working on this, okay, during the 2014, which is called as a global earthquake model. Okay. So this was the second global level seismic hazard mapping. So this was done by the global earthquake hazard and risk model. So key priority was GEM, it is called as a GEM. So where to take a seismic hazard analysis of the entire globe and publish that map, so that we will know that on today, okay, as on 2018 or 19, what was the hazard status of the entire globe. So by the 2014 this one, we had at least reasonably good seismic data in the globe. Okay, so there was a global seismic network which we have seen. Okay, so the global seismic network, regional seismic network established. So the objective is to collaboratively develop a complete set, okay, earthquake data and models, and to deliver comprehensive global assessment earthquake risk map of the entire globe and each country wise. So the mosaic of collection of 30 national and regional seismic hazard models covering the entire globe, the inconsistent with the hazard models developed by the various institutes in the country within the collaborative projects and by GEM Foundation, all described in the consistent format compatible with the open quark engine. So where this map is actually more interactive in nature. Okay. So this map and about the report can be found in this reference. Those who are interested to get more information about that, you can browse this page and get the information. So this, the entire globe, the divide depends upon the research group involved. Okay. So basically the color of code indicates that a same research group has been handled all this continent. For example, the India, okay, then this one, and Canada, so and the NAF handled by the similar kind of group of people. Similarly, USA, okay, so NES handled by the similar kind of group. The South America and then the Europe and then the Arabian region handled by the similar group. So where the group of scientists working together, Australia and the sea, this, so all those people are actually basic. So this somehow if you see this mapping, okay, the coloring scheme, you can also understand that these regions basically similar kind of tectonic in nature. Okay, that also you can get some extent from this. So, this informations are compiled from each country and each research group, and finally they produce seismic hazard map at a global level. Okay. So, the GEM global mosaic of seismic hazard model. So, the global earthquake model GEM global seismic hazard version 2008, basically the year 1 is actually the first version. So, depicts a geographical distribution of the peak ground acceleration with the 10% probability being exceeded in the 50 years, computed for the reference rock condition with VS30 of so much. So, you can see that they have done basically seismic hazard analysis, okay, using the probabilistic approach, okay, which is the first step in the seismic microresonation. That is what they consider this hazard value at the bedrock level. Okay. So, the map was created by collecting a map computed using the national and international probabilistic seismic models developed by the various institute and project by GEM Foundation scientists. Okay, the group of people who are, so they talk to the each country who are working in this area. So, the open co-op engine or open source seismic hazard risk calculation software developed principally by the GEM Foundation and used by the calculate hazard values at all the places. So, the smoothing methodology was applied to homogenize hazard values, okay, along the model borders. So, the map is based on the database of hazard model described using the open co-op engine data format, NRLM is called. Those models originally implemented other software format were converted to this format. While translating these models, various checks were performed to test compatibility between the original result and the new result computed using the open co-op engine. So, overall the difference between the original and translated model result are small, notwithstanding some diversity in modeling methodologies implemented in the hazard modeling software. So, they have seen that even though the work was done regional level individually, they clubbed together all the data, and see that these maps are representing the same original research and also it is uniform throughout the world. That was the main priority. Okay. The acid area on the map like Greenland are currently not covered, okay, hazard model. So, the map underlying database models are dynamic framework. It is capable of incorporating a new release open models. Due to possible model limitations, regions portrayed with low hazard may still experience a potentially damaging earthquakes. So, they say that this model, okay, whatever the model they used, some of the places the lack of proper model and lack of data, that means it may shown in the map a low seismicity or low PGA value, but there may be potential damaging earthquake can be expected in this region. So, that is what I told you, that none of the world area is free from earthquake, only you have the lack of data, you cannot claim that this is more accurate. Okay, there may be earthquake which you can expect in those regions. So, the GEM Foundation plans to release future update of this map on regular basis as on the new information and data are obtained. So, basically they develop a model, okay, and then they consider all the information consider in the developing model as a entity, where if you key the new information the map will change automatically. Okay. So, this is the global earthquake model. So, this is a mosaic of 30 national and regional hazard model covering the entire globe. The consistent hazard model developed by the various institutes with the collaborative. You can see this is the map. So, here basically you can see the hazard distribution at different places. You can see that overall the plate boundaries you have the more seismic hazard, okay, when compared to the non-plate boundary regions. You can also see the PGA distribution. This is actually the peak ground acceleration in the unit of G with the 10% probability being exceedance in the 50 years equivalent return period of 470 years. So, as I told you that the map is more interactive in nature. So, this is actually the image file what I got from the website and put it here. If I go for the website, the same thing, Okay, so you can go for the website. So this is basically the website where your maps are published. So if you want the image file, you can take it from here by registering your email and other details. So if you want to see this map, okay, go to the hazard viewer. So we understand how this map was prepared. You can see now, see I can get a map at a different places what I want. See, Shimaga, Mandya, Bangalore, see. So the Bangalore, what is the hazard value? So this is the Bangalore is actually in a dark color, I mean the green color. So the green hazard is actually, how much the green hazard legend? Let's see the legend here. Okay, so legend here. So you can see this was about 0.08 to 0.13. So you can see the difference, okay, so which is previously what we discussed. He mapped most of the southern India as a region with less than 0.05 G. Here you can see that in the Bangalore, okay, so what we have seen the Bangalore, and then the other part, okay, India other part, you can see the values. Okay, you can see the hazard values. Even this is the Koyna region, you can see the Mumbai, Koyna region, Hyderabad. Okay, so even you can see there is a, so the lowest hazard value, okay, mostly expected was more than 0.01 G. Okay, so the highest hazard value which is expected at this very dark red region. Okay, so where you can see around this close to 1 G, that is on the plate boundary. So this kind of interactive way you can get a information what you want. So you can also get a like the different color you can get. Okay, so like this you can create a different interactive way. Okay, so that is the one beauty of this map. Okay, so you can get a hazard map of the this one. So you can also zoom in, and then you can also get a information. So what you want. Okay, so you can see the map which is interactive in nature. So this kind of map is needed for each city, so that somebody here, but here this is the global scale. So the India variation they have shown, but the city variations are not shown. Okay, for example, Bangalore, if I want to go inside the Bangalore, I think I cannot go beyond some zooming level. Okay, so highest level I can zoom is only this much. Okay, so where the Bangalore is shown as only a point. Okay, so it is not gone beyond this information. Okay, but now the micro-zonation what the map they give, they should create a similar kind of map, and then if you zoom into Bangalore, I am giving you the example. So IAC, I should know what is the hazard. I should know what is the hazard at the JP Nagar. I should know what is the hazard at the Majestic. I should know what is the hazard at the airport. I should know what is the hazard at the electronic city. Such kind of a minor variation, okay, a zoomed in value should be available part of the micro-zonation mapping. So I think the MOES work what they are going to do, they are going to achieve this kind of things in their studies. Okay, that is what they are working towards that. So this hazard map, okay, it's not only end up only the mapping a PGA. So this way, this is like global scale. Somebody want to locate, okay, what is my hazard value? So they will get from here, and maybe that can be taken as a reference to do some kind of calculation or anything what they are looking for. Okay, but this micro level information is not there, only macro level you get, and it is a very interactive way. As they said that these maps could be capable of updating frequently by changing your model as well as the data. How these maps are useful, why they develop this map, okay, which we are going to discuss in the next class. Okay. So this is the macro zonation, like a global or continent or country wise zonation map which is available as on now. So, which is like maybe the better way to represent as a India, but locally city wise represented may not be possible. But why they do it on larger scale and what is the importance of that, what additional input they develop, part of this we will be going to discuss with the continuation of this class in the next class. So, thank you very much for watching this video. So, we will meet in the next class on discussing continuing this the GEM model and related results. Thank you very much.